All right, today we're going to talk about solving systems with graphing. Okay, so I guess the first question is, what's a system? Well, a system is simply two or more equations that have, hopefully, something in common. For instance, let me write one up here. Y equals 2x plus 7, and y equals x plus 6. Okay, so really that's all a system is, just a couple of equations. Now sometimes you'll see a little bracket over there on the side that indicates that these have something to do with one another. But essentially, again, when I ask you to solve a system, what I'm asking is, if you were to graph these, if you were to graph this line and this line, where do they cross? Okay, that's as simple as you can make it. So let's give that a shot. So if I want to solve this, I want to know where do those things cross. All right, so let's try that. Let's on the graph that's down here below, I'm going to graph these two. So let's graph the top one, y equals 2x plus 7. So let's just list a couple things. 1, my slope, which is 2. My y-intercept is 7. So I'm going to go up here, 1, 2, 3, 4, 5, 6, 7. There's my y-intercept. And then my slope is 2, so I can just go up 2 to the right 1. Or I could have gone down 2 to the left 1. Okay, and then I'm going to draw a line. Okay, so hopefully my hand is steady here. Okay, next, let's do this one. We'll do this one in red so we keep them separate. So this one, slope is 1, y-intercept is 6. So I'm going to go up 1, 2, 3, 4, 5, 6. And since my slope is 1, that means I go up 1 to the right 1, up 1 to the right 1. Or I could have went down 1 to the left 1, down 1 to the left 1. And you see that looks like we have an intersection point right there. So where is my intersection point? Well, I got to count it. So that's -1, comma 1, 2, 3, 4, 5. So my solution to this system is -1, 5. Why is that my solution? Because as I look at my graph, that is where they cross, at -1, 5. How else could I determine that? Well, what I could do to check to see if that's really a solution is I could plug -1, 5 into this equation up here. So I could plug 5 here and -1 here. And then I can do that down here as well. Put 5 here and -1 here. And if with both those equations, if they come out to be true, both, not just one of them, then that is the solution. And I promise you it is. Okay. So now as you look at this, you can kind of tell right from just doing this one problem some of the disadvantages of graphing. One is it takes a little bit of time. Two is if my solution is not exactly on one of these little points on the graph, then the graphing method is not really all that successful because I'd have to guess, and I don't want to have to guess. But like I said, there's definitely, it's nice to be able to put a visualization with it, so, or a visual aid with the solving. So that's why we learn it. Okay, so let's try another one. What if I give you this system? 3y minus 3x equals 3, and 2x plus 4y equals 16. All right, so let's go through and do some graphs here. Well, you can tell right now we got some problems here. Looks like we're going to, neither one of these is in slope-intercept form. Okay, so you're going to have to put those in the slope-intercept form. So let's start with the first one. So 3y minus 3x equals 3. First thing, I'm going to add 3x. 3y equals 3x plus 3. Divide by 3. So y equals x plus 1. So slope is 1, y-intercept is 1. All right, let's do the other one. I'll do that over here. 2x plus 4y equals 16. So let's subtract 2x. So 4y equals negative 2x plus 16. Divide by 4. Y equals, now negative 2 over 4, that'll reduce to negative 1/2. 4 divides into 16 4 times. So slope negative 1/2, y-intercept 4. Okay, so let's see what the solution is. So let's graph these. So if this one, y-intercept's 1, and then my slope's 1, I'm going to go up 1 to the right 1, up 1 to the right 1, or I could have went down 1 to the left 1. And then I draw my line. Okay. This one, y-intercept's 4, 1, 2, 3, 4, down 1 to the right 2, down 1 to the right 2, and there you go. And it looks like right there is our point of intersection, and that's at 2, 3. So my solution is 2, 3. You got to remember, your solution is always a point, so you got to make sure you write it as a point. Don't just leave it, as a circle here or anything like that. Okay, let's try one more. I'm going to do one more, and then we'll call it quits with these types. Let's see here. How about this one? Y minus 2x equals 3, and y equals 2x plus 5. So the bottom one looks like it's already set up for us, so we can just write slope's 2, y-intercept is 5. Okay, now the top one we don't have yet, so let's go through and do that. Let's rewrite that. So let me do it over here. Y minus 2x equals 3. Okay, so let's just add 2x. So y equals 2x plus 3. Looks like my y-intercept is 3 and my slope is 2. Okay, so let's come back to the first one and let's graph it. So intercept is 1, 2, 3, 4, 5. My slope is 2, so I can go up 2 to the right 1, up 2 to the right 1, or I could have went down 2 to the left 1 if you wanted, down 2 to the left 1, and graph. All right, so let's do the other one. Looks like my y-intercept's 3, 1, 2, 3, and then you go up 2 to the right 1, up 2 to the right 1, or down 2 to the left 1, and kind of a funny thing happens. They don't ever cross. Well, why would we have known that before we even graphed? Well, we should have known that because right here you see that the slopes are the same. And we know that if slopes are the same, then that means they're going to be parallel. Well, then what's the solution to this? Well, since they don't ever cross, that means there is no solution because there is no point that they have in common. Okay, that's it. That's how you go about solving systems using graphing.